Okay, so here we'll be looking at what are the different kinds of real numbers which are possible, and we'll differentiate them and their properties. So real numbers can be basically divided into two parts. One is called rational numbers and the others are called irrational numbers. Now rational numbers are those numbers which can be basically represented into a P upon Q form. So any numbers which could be represented in P upon Q form is a rational number. So they could be integers, because even if an integer is, suppose 2 is an integer, so 2 can be written as 2 upon 1, so therefore it becomes a rational number. Similarly, it could be a decimal, for example 0.332. So this is a terminating decimal because there is no numbers after 2, no digits after 2, so this becomes a terminal decimal, and this can also be represented again 0.332 upon 1, so it's a rational number. Similarly, we have got something called a recurring decimals, so this could be 0.3333 and so on. So these are recurring decimals, but in the next lecture we'll see that even a recurring decimal could be written into a P upon Q form. We'll look that conversion in the next lecture, and as they can be written in P upon Q form, they are also rational numbers. So all the numbers which could be written in P upon Q form are rational numbers. Now what are irrational numbers then? Irrational numbers are those which have a non-terminating, non-recurring decimal representation. So for example, if we have a number of, suppose let's take the constant pi. We all know that pi has a value of 3.14, but actually this is not the exact value. There is more continuation to it. 3.14 is just an approximation for pi. So we see that this pi value can never be written in P upon Q form. Note that the 22 upon 7 which we take as value of pi is only an approximation. It's not the exact value of pi. So it can never be written in P upon Q form. So therefore pi becomes an irrational number. Now other irrational numbers could be, it could be root 2, root 5. All these numbers don't have a terminating decimal expansion. So these are irrational numbers. Note that these irrational numbers could also be represented on a number line, because ultimately both of them are real numbers. All real numbers could be represented on the real number line. Okay. So we have to note the main thing here is that any terminating or recurring decimal is a rational number. The conversion of recurring decimal to P upon Q form we'll look into in the next lecture. But as it can be represented in P upon Q form, it is a rational number. Similarly, any non-terminating, non-recurring decimal is an irrational number. Okay. So now we'll go further into detail. The rational numbers could be divided into further. So we will study something called integers. So what are integers? Integers could be negative numbers, could be 0, or could be positive numbers. But for integers, the decimal part has to be nil. So there is no decimal part. So decimal part is 0. So the example of integers could be, negative integers could be -2, -3, or anything, -68, but there should not be a decimal part to it. Similarly, 0 is also an integer, and then we have other positive integers could be 2, 5, 6, or anything. Now integers, the positive integers and 0 if combined, so if these two are combined, it becomes the group of whole numbers. So these are called whole numbers if we combine the positive integers and the 0 value. And the natural numbers, so natural numbers are those which are positive integers. So we are not taking any 0 in that case. So that's the difference between whole numbers and natural numbers. The only difference is whole numbers contain 0 and natural numbers does not contain 0. It only has the positive integers. Okay, so now these positive integers, that is the natural numbers, could further be divided into prime and composite numbers. Now what are prime numbers? Prime numbers are those numbers which have only two factors. So prime numbers have got only two factors, and those two factors are 1. So 1 is a factor of in fact every positive number, and the other factor is the number itself. So let's look at the smallest prime number. The smallest prime number is 2. Why? Because the factors of 2 are 1 and 2. So there are only two factors, 1 and the number itself. So 2 is a prime number. Similarly 3, we have only two factors, 1 and 3. So it becomes a prime number. But for 4, we have factor of 1 is a factor of 4, 2 is a factor of 4, and 4 is a factor of 4. So basically we have three factors. So this is not a prime number, and therefore it's a composite number. So all those positive integers which are not prime numbers are called composite numbers. But note that we are still left with one positive integer, that is 1. It has only one factor, that is 1 itself. So this is neither a prime nor a composite number. Neither a prime nor a composite number. Okay, so that's all I wanted to cover in this lecture.